Okay, everyone, welcome to the OWASP London chapter. This is our July meetup. We are live streaming this event on YouTube, and tonight's event is kindly sponsored by RiverSafe. We're providing pizza, beer, and the raffle prize, and it is kindly hosted by Zoopla. So I'm going to invite Victoria from Zoopla to tell us a little bit about this venue and where the toilets are and things like that.
Hi, everyone. Welcome to Zoopla office. Wow. So we do not have any fire alarms planned. If you hear one, there's probably a fire. Either go the way that you came in, or there is another exit just on that end by the pool table. The bathrooms, if you exit this room, carry on towards the reception, is going to be on your left. If you visit our site, we are hiring, not in security, unfortunately, but in engineering. Please come join us. We are a cool place to work. Thank you, Sam.
Excellent. And okay, for those of you who don't know me, my name is Sam Stepanyan. I'm one of OWASP London chapter leaders. We have three OWASP London leaders, myself, Andre Letz, and Sharif Mansour. Andre and Sharif, unfortunately, cannot be here. Those who attend our events a lot know that Sharif was diagnosed with cancer last year with leukemia, and he undertook a course of chemotherapy and treatment, but he's in remission now, so we are looking forward to him coming back, hopefully in the next couple of months. So that's the news on Sharif. For those of you who are going to take pictures and tweet and post on LinkedIn about this event, we're more than welcome to do it. But please do use hashtag OWASP London and mention us. We're OWASP London on all the platforms to make it easier for people to find us. Very quickly about our code of conduct. We are a very comfortable and friendly community to everyone. So please be nice and respectful to each other. Any issues, please do let us know, because we do have a code of conduct. Now, tonight's agenda has been reshuffled. We're going to have Donato to speak first about testing LLM applications in the real world. Then we're going to have a 10-minute break for more pizza, drinks, chit-chat, and then we're going to have Viola to talk about how real attackers move from session replay to broken authentication and MCP abuse. Then we're going to have a prize giving and a raffle and a prize giving, and then we're going to have an after party. So those of you who are willing to stick out with us for a bit longer, we're going to go to the pub which is next door. Hopefully you've seen it all when you came in, called Dean Swift. Now, how many people are attending this event for the first time? With a show of hands. Oh, excellent. Quite a few of you. So thank you for finding us. I have no idea how you managed to find our event, but to make sure you don't miss the next one, these are all the different ways how you can make sure you don't miss the event. So first of all, we have an old-fashioned mailing list, which will send you an email notifying you about next event. It is based on Google Groups, so you can sign up if you visit our webpage, owas.org/London. We are on Twitter, or X as it's known, on Facebook, on Meetup, on Eventbrite, on LinkedIn, on Mastodon, on Blue Sky. We're also on YouTube, where we have our channel called OWASP London, where we are live streaming this event right now. And if you subscribe to it, you will be able to be notified when the next video is published, and because all the talks will be published, and also we are live streaming. So if next time you are unable to come, you can watch it from the convenience of your home or on your mobile phone. Now, we do have a raffle prize tonight. And yeah, we're sorry that England didn't win it, but here's a chance for you to win it. Right? So if you do scan this QR code and enter the raffle, and also tick the box if you're interested to find out what our sponsor RiverSafe, who's kindly provided the pizza and drinks and this prize tonight. I will actually invite the RiverSafe representative in a minute. But yeah, that's the prize which is coming up. You will find these QR codes stuck on the pillars. So during the break, you can try and get them. Okay, now let me see if my audio is going to work. So play a short video, 1-minute video about OWASP.
OWASP is a nonprofit that stands for the Open Web Application Security Project. OWASP is a community of developers, technologists, and evangelists improving the security of software through tools and resources. OWASP has 100+ active projects, and new project applications are submitted weekly. Projects are open source and are built by our community of volunteers, people just like you. Community and networking. There are hundreds of local chapters worldwide and thousands of members. Meetings are free and open to everyone. They include training, talks, and networking opportunities. Education and training. OWASP hosts many events each year. They are a great way to improve your skills, build your professional network, and learn about new trends in the industry. One of the many ways you can get involved is to become a member. The membership benefits include discounts for events and trainings, your own OWASP email address and Google Workspace access, a vote in our OWASP Global Board elections. And recently, OWASP added a brand new member benefit, access to hands-on application security training through the OWASP Secure Flag Open Platform. Join us and become a member today.
Wonderful. All right. So as mentioned in the video, we have chapters worldwide. So people watching us live from other countries, please do check out an OWASP chapter near you. In the UK, London is not the only chapter. We have quite a lot of chapters in the UK, and actually a chapter leader from Dorset is here tonight. So great to see Aaron. So yeah, if you are located somewhere else here, your friends elsewhere in the UK, please do tell them about OWASP and OWASP chapters, because they will have an opportunity to attend the events and learn from the speakers and the training events everywhere. Okay, now for the first time ever, OWASP released the impact report. So we are a nonprofit, we're an educational charity. We've been around for 25 years, and we released our impact report where you can learn a lot about our projects, all the good work that we're doing. So do check it out. It's absolutely awesome document available as PDF for you. Now, as mentioned, benefits of becoming OWASP member includes Secure Flag training, which is a lab-based training system, which has lots of challenges in different programming languages and just hacking challenges as well. Now, another benefit for OWASP members is a system called Aikido, which is an application security platform utilizing AI. And that is a brand new benefit, which has just been announced a month ago. So if you scan this QR code, you will find everything about it. So when you join OWASP as a member, you can now get 200 credits on the Aikido platform. So thank you, Aikido, for providing this benefit to us. Now, you've seen that OWASP has a paid membership, so it is only $50 a year, or about 36 pounds in our British money, depending on the inflation and the currency exchange. For students, it's $20 a year. And obviously, we also have packages for corporate supporters. So if you represent a company and you wish to sponsor OWASP and open source security community, you are more than welcome to join us. Now, if you join OWASP as a member, obviously you will get not just all these benefits. There's one extra benefit that only I give, because you see this sticker. This is a vintage super rare sticker, because this it has an old OWASP logo, which is no longer a new OWASP logo. But this is the only membership sticker we ever did. And if you become a member tonight and you go to the OWASP.org membership or become an OWASP member and show me the confirmation email, I will give you this exclusive and super rare vintage OWASP member sticker. Now, there is one extra thing that I will give to you apart from the sticker. If you become a member tonight, I will also give you a discount code which will allow you to go through Try Hack Me, another sponsor of ours, which recently launched the AI Security Level 1 exams. They have several security levels, so Security Level 1 is now launched. And if you know, Try Hack Me is an educational platform, it's a training platform where you can learn about cybersecurity, and they have a certification. And this certification exam usually costs £299, but it will be absolutely zero free if you become a member of OWASP tonight. Now, we are a non-profit organization, so we are vendor neutral, but we are supported by multiple sponsors, by vendors, and we thank them a lot. So if you want to become a member, and as you can see, we are in Zupla office tonight. If you have similar offices and you can host an event like this, please come and talk to me, because we might have next event at your offices. Now, let's all thank Zupla for this wonderful office one more time. And I would like to invite the representative from RiverSafe to talk a little bit about their company, because obviously they are kindly provided us with pizza and drinks and the raffle prize. But let's find out who they are and what they do.
Thank you, Sam. Unfortunately, Sam almost covered everything that I was thinking about, right from the raffle prizes to the pizza and drinks. But nonetheless, here I am. I'm Vish from RiverSafe, and we are your official sponsor for the evening for pizza and drinks. Again, reiterating what Sam said, because to be very honest, it's always good to be in a with a full stomach, isn't it? So RiverSafe, if you look at us, we help our customers and organization in reducing their cyber risk and helping them transform their AI adoption journey. We have got few people in the room right now. One is myself, another one is Timmy in the back. So if at all you wanna come say hi to us, we'll be more than happy to have some chit chat with you. And for the tonight, we all obviously have got a raffle prize. So hold on to your name tags, please scan and make sure that you are holding on to your World Cup knowledge, because it's related something to that. And hopefully one of you will be lucky to take the raffle back to your home. With that, my one and only security objective for tonight is to ensure there's no distributed denial of services for your pizza and for your drinks. Thank you, everyone, and have a great evening.
Now, obviously, as you have seen, OWASP celebrates its 25th anniversary this year. We've been telling people about vulnerabilities and web applications and software applications for the past 25 years, since year 2001. We did have a party and we had a massive cake, and you missed it if you weren't there. But those of you who were there, I see some people who were there, they did try it. So that was an awesome party. Now, what's going to happen this year is a lot of OWASP chapters all around the world. There were 12 OWASP chapters, including us, London, selected to run these parties. So yeah, there will be more parties worldwide. And we will have a virtual conference celebrating 25th anniversary in September. Now, if you'd like some OWASP merch, like a t-shirt, or we have some nice 25th anniversary cornucopia cards for threat modeling, we now have a brand new merch store, which has now just been launched. So if you go to owasp.org/store, you will be able to purchase our merchandise, and obviously a portion of the proceeds will go to us to support OWASP as a charity. We just had our global conference in Vienna. So OWASP runs 3 conferences a year, one in Europe, one in Singapore, and one in the United States. So the one in Europe was in Vienna this year. We're going to have another conference in San Francisco in November. So the call for speakers is just closed. But if your company is in cybersecurity space and you would like to present and have a booth in front of 1,000 attendees who are all security practitioners, people in the industry, here's your chance to exhibit a sponsor this conference. Again, there are over 1,000 people attending, and it is in San Francisco, running first week of November. OWASP is known for its open source projects. It's not just OWASP Top 10. We have over 250 projects. So tonight I'm going to highlight 2 projects. First, the project you probably didn't know existed, but we've just launched OWASP AI Security Verification Standard, version 1.0. So it is now available for you. Please do join. This is the first draft version, but this is an actual standard which has 3 levels, just like the old OWASP application security verification standard. This is how you can actually verify that your AI applications are secure. So this is brand new. And next, I'm going to invite on stage John Soteropoulos. John's going to talk about brand new quantum security project.
Thank you. Well, I want to say what a privilege to be here. We're all a force of change, of positive change. Technology moves very fast, and with that we get bullshit, we get fear, we get headlines, and of course LinkedIn posts. And this is where OWASP comes and takes that, dilutes it, and makes it actionable and reliable. So on behalf of the Gen AI Security Project, the other project I'm on, thank you, and I couldn't support more Sam's ask to join OWASP as a member. The time has come to look at another area, quantum. So we just launched the quantum security application. I think it's the readiness is the first wave that we want to evaluate. So what does it mean for organizations? Because I think we'll again see all the fear, all the hype. So we're planning to have a top 10 in November. Very, very kindly, Sam has the QR code. There is the GitHub. We are having monthly calls. If you find me on LinkedIn, or we'll post also on the LinkedIn, come and join us, because after the top 10, we also want to do a threat model. What does it mean, quantum, to have quantum applications? You know, what are any other risks? Is there any possibility that you may have quantum-backed adversarial AI? Those are the kind of things we want to explore, and let's explore together. So thank you.
Everyone should, yeah, one more thing.
It was so good that many organizations invited us. So I'm doing the training course for AI red teaming, including the tool that you're going to see in a minute. You know, come and join. It's so cheap, it's fast. Come and join and learn AI red teaming. That's aligned to OWASP. In September, 21st, 22nd of October. Sorry, September.
Excellent, excellent. Thank you, John. And speaking of quantum, right, a lot of people think, oh, quantum is the thing which is far away. It is not, because I was recently invited to IBM offices, which are just near Waterloo, and they already have 20 quantum computers in that building and worldwide. And the cost of the quantum computer is now dropping below $10 million. And you think it's a lot of money, but it's not, because it's not cheaper than yacht, right? And if you go and look at the River Thames, and you can see that also people who have their own yachts and their own boats and ships, right? So, you know, it's getting cheaper and cheaper, and we need to be prepared. So it's very important for us as OWASP, because remember that cryptographic failures is one of items on OWASP top 10. So we need to be prepared. So please join that project. Now, how to ask questions today for people in the audience and people watching us live. We're using Slido system, slido.com/OWASP. Of course, I will run around with microphones, but if you think of a question during the talk, please do ask it online, because it will be easier for us. Now, with a reshuffled agenda, I'm going to invite Donato on stage. So for those of you who don't know Donato, Donato is a security engineer and software developer and researcher who's been doing some amazing AI security research. And he's been doing it for a long time now, over 3 years. He's been speaking at many conferences. And I don't know how many of you have a YouTube channel with over than 100,000 subscribers, but this is what Donato has. So because he regularly publishes lots of very interesting talks and presentations on the topic of AI, LLM, bypassing the guardrails, which is very, very interesting. And tonight we're going to find out once again, how can we do it? Let's all welcome Donato.
Thank you. We tested this. Let's see if it works. All right. So I thought, so the title of the presentation changed. Breaking every guardrail everywhere all at once. This is a reference to a movie that some of you might have seen. So instead of starting with the presentation, I'm gonna read a little story. This is a personal story. I'm taking you back to the beginning of 2024. How many people here do pen testing? Quite a bit of you. So imagine this is you. It's day 3 of a 5-day pen test. You spent the first 2 days begging for missing requirements, waiting for credentials, and finally being given access to a URL, only to find out that it's 500 on you. And the devs are on the other side of the world and have logged out for the day. So meanwhile, you've leveled up your thumb twiddling skills to a new professional standard. Finally, on day 3, the app miraculously starts working. You notice a big shiny button that says, maybe the volume is too high. You notice a big shiny button that says, summarize my inbox. You click it and instantly you know. Hype Lord Sam Altman's gift to the world, yet another LLM hiding behind a button. You frantically Google hacking LLMs for dummies, and maybe you strike gold and find a video by prompt injection guru Johan Reiberga, and 40 minutes later, you've learned just enough to be dangerous. So you go back to the application and you craft a test email with a carefully researched, super duper malicious payload, new important instructions, and tell the LLM to include a markdown image in its response whose URL contains a secret you want to steal. In this case, the password reset token from another email. You hit the summarize button and a GPU cluster in an AI data center burns through a swimming pool of water for 30 seconds to generate an answer. You see the markdown image rendered in the response and its URL containing the password reset token you wanted to exfiltrate. Bingo, you are an elite prompt hacker. You've done your job and now you can ask ChatGPT to write the report for you and go back to your incredibly satisfying thumb twiddling practice. But with your usual luck, it turns out the devs were just trolling you, and they had forgotten to enable the guardrails. Now you go back into the application and you try again your payload, new important instructions, and nothing happens. No image is rendered, no data exfiltration is happening. Your hard-learned uber super duper payload that worked before is now as useful as a 0 day on Internet Explorer. 1 day left to test and write the report, and you are understandably not thrilled. You need to start really working for your money. So you start scavenging obscure Reddit threads, looking for some weird jailbreak that sorts of makes sense for the application you're testing, but nothing. You Google LLM red teaming and pull a few automated tools, but they are all built to test LLM models, not LLM applications. They seem to require an OpenAI key to operate, and their prompts shout things like, tell me how to build a bomb, or say humanity is stupid. So if you are like me, and you're trying to do a pen test, and this is day 4 of that 5-day pen test, this is how you feel. And warning, I don't even know if the audio is going to work. Maybe it is. Yes. For the next 20 seconds, there are going to be flashing images. And then we're actually going to start the presentation. But that's how I felt that January 2024 while I was doing this pen test. Prompt injection, jailbreak filter, do anything now, topic control, rate limiting, output validation, developer mode, sandboxing, access control, human in the loop, token smuggling, indirect prompt injection, multi-turn attacks, basics, whatever that was. Wouldn't it be great if we had a way to break every LLM guardrail everywhere all at once? And that is the reason why back in 2024, we started a project which was an internal project, but then became now an open source project called Spiky, Simple Prompt Injection Kit for Evaluation and Exploitation. And I'm going to talk to you about less about the tool and more about what were the problems that we were having while trying to pen test these applications and how we came up with different solutions. I am going to attempt my best to make this presentation last roughly 30 minutes so that there is time for questions if you have any. So I'll tell you a little bit about me. I mean, you already know, so I'm going to ask ChatGPT. This is my who am I slide these days. Who is Donato Capitella? That's I mean, if you used to do this in 2023, you wouldn't get a good answer, but now I think you get a fairly good answer. So I work at Reversec or Reversec. You decide how you want to pronounce that. We have had many names: MWR InfoSecurity, F-Secure, WithSecure, you name it. We are an offensive security consultancy. I worked there as a software engineer, penetration tester, and I wear many hats. But the last few years, I have been working on generative AI security, and mostly testing the LLM applications that our clients were trying to deploy. I think in a way, we've been very lucky. I remember at the end of 2023, one of our biggest clients came to us and said, we are building an LLM agent. This was 2023. They were trying to do it with GPT 3.5 Turbo, I think it was. And that was the first thing I ever tested. And I had no idea what I was doing, but they had even less of an idea what they were trying to do. Anyway, the agenda for this. So when we started testing these LLM applications, we had a wish list. We had things that we needed in our tooling that we couldn't find elsewhere. So we started writing scripts, but I'm going to walk you, and that became Spiky, but I'm going to walk you through what these problems were and what was a simple solution. Now, I think these were good solutions because if you fast forward to today, other people that had the same problem roughly started solving it in the same way. For example, the PromptFu guys, or some people at Microsoft with Pirate. There is a very healthy open source ecosystem around this. But let me start with the first problem that we had. So when I was looking for tooling to pen test LLMs, I found LLM red teaming. So there was, and there is, something called Garak. Very academic tool. The people that make it are fantastic, but it was a very academic tool geared towards an LLM in isolation, an inference endpoint, which was totally useless to me when I was testing a summarization button in a web application. What am I going to do with that? So my problem was that my clients already in 2024 were building things that were not just LLMs. They were building what we would call agents now. And so we needed a simple way to abstract Spiky from the interface that the solution had. And obviously, Spiky is modular, and the way that we did it For every application that you want to test, for every endpoint that you need to test, you can simply implement a target, which is, I mean, you vibe code it. I haven't written one of these myself in ages. Any LLM is able to write this if you give it the API endpoints. But this allows us to test anything that would interact or be powered by an LLM. Some of the things that, for example, we have done, I remember banging my head against the wall for this. So we had a use case where you had to upload some documents, some files on an S3 bucket, call a Lambda function that would process the files, and then you would need to go into the CloudWatch logs to see if any of your attacks worked. I mean, you can write you can get an LLM to write to you a couple of lines of code that can allow Spiky to talk to that in a way that can send a payload and can check the output. And also some of the other problems that sometimes we have, when you have WebSocket applications that are very common with chatbots, it's a pain to even try to implement that protocol. You can do it with Playwright. But the point is, we abstracted completely Spiky from what we were testing. And the beginning of every test, the first 10 minutes is vibe code, something like that. Easy problem solved. Now, the second problem, and the most important one, like if you take a couple of things away from here, this is one of the most important things, the customizable data sets. So you see, the problem is, if you have an LLM and you are doing LLM red teaming, so you have a list of general purpose safety things. Tell me how to build a bomb with household items. That's one thing. But if you have an LLM agent or application, the things that you are going to ask that you want to achieve need to be very targeted to whatever the use case of that application is. And so what we needed was a way to take all of the prompt injection techniques or jailbreaks. And by the way, I use prompt injection and jailbreaks interchangeably. We could have arguments on this for a couple of centuries. They're probably different, but like allow me to use them interchangeably. But then when I look at, for example, the use case that I was showing you before, I send an email and there is a mailbox and a button to summarize that mailbox. Now, what is it that goes into the LLM? That entire prompt, summarize the following emails with all of the emails. Me as an attacker, I obviously only control the email that I am sending. I don't control the system prompt. I don't control the other emails. I don't control the instruction. So I need to be able to define in Spiky what's the shape of the type of input that I am sending. Is it a Jira ticket? Is it a Word document? Is it a prompt for a chatbot? But very unlikely, it is the entire input to the LLM. Once I do that, if you look at the attack, I have the regular document, that's just an email, and then I have what I typically call a jailbreak, which is a language pattern that allows me to disalign the LLM, to make it do something I want to do. So you know them, I'm not gonna read them, and you can find your own. But that is different from what I want the LLM to do in that particular case. What is my malicious intent? In that case, data exfiltration via markdown images. But that intent and what makes sense for an attacker to do really depends on the use case. Tell me how to make a Molotov cocktail doesn't make sense in this use case. You should not be sending that payload there. You are wasting inference time and your own time, and you're giving zero value. But then the people that read your report maybe don't understand, and everybody starts screaming, and it becomes a nightmare. So you need to really think of what are the malicious outcomes that you want. And for me, I have kind of everybody talks about, again, the safety layer. Okay, that does matter. But when we are in cybersecurity, I talk about all of the agentic stuff, or even just not agentic, but data exfiltration, typical attacks like cross-site scripting, distributed denial of service, authorization bypass, server-side request forgery, anything that you can get the LLM to do in that particular circumstance. You can also have topic control. I don't find this particularly interesting, but our financial clients love this. They are so scared that somebody is going to go to their chatbot and say, tell me how to invest my money, and then they are liable for that. I keep telling them, we can test that for you. We can help make it difficult for somebody to do that, but you're not going to be sued if you have a message that says, don't trust, this is not for investment. Anyway, you can test whether that particular system can stay on topic. And it is actually possible to make it very hard for somebody to make a very particularly scoped system to go out of topic. Anyway, the way that we solve this in Spiky, we have a bunch of, so we don't give you data sets that are ready to use. If you don't use your brain, or if you don't use the brain of an LLM to customize your data set, you are always going to end up with a generic data set. There needs to be some reasoning, either your reasoning or that of your favorite butler LLM, to compose a data set that makes sense for the application that you want to be tested. Now, what we give is, again, this list of seeds that typically allow you to define the shape of the user input, allow you to select from a set of jailbreaks, so come up with new jailbreaks, and then a set of instructions that you want to use. And then all of this gets combined together. So this allows you to essentially get a meaningful, context-relevant data set and tailor it to the constraint of your test. Like, sometimes I go to my client and I say, how many prompts can I send, or how many emails can I send to this application? And the answer is very seldom 100,000. Like, so you need to be conscious. If they say you can only send 500 emails or 500 Jira tickets to this system, you really need to think of what your data set needs to look like to make very good use of what you're asking. And if that's tell me how to build a bomb, I don't think, unless in that use case it makes sense, I think you're just wasting time. Now, I'm going to give you an example of what this is like. So this is the sample application that I have recreated. You've seen it. I click summarize my mailbox, and I get a summary of what's in my mailbox, right? So the way that I would approach this with Spiky, so Spiky works on the concept of you need a repository. You create a workspace, which becomes the repository for this project. And then you have this kind of seeds that you can create data sets from. So in this particular case, I have already prepared my seeds. I have documents which are base user inputs. In this case, I have one email, but I could have different emails, a longer one, a shorter one. It could be prompts, it could be Jira tickets, it could be anything that makes sense for the application that I'm testing. There is nothing malicious in here, but these are gonna carry my payloads into the system. Then I should probably talk as the video goes. Then we have a set of jailbreaks. Now we have a static set of well-known jailbreaks, and then you can generate more using an LLM or even manually, or you can customize them. The idea is that customizing these takes 3 seconds. You have a new one, you add it in, you ask an LLM to generate some. This is really an easy file to customize. And then you have the instructions, which is the part where you have to spend the most time. And in this particular case, I am using, as an example, data exfiltration. This is very tailored to what I want to do. I want to steal information from that mailbox using markdown images as an exfiltration vector. And then I think I show it, I highlight it. But then I also need to tell Spiky how it knows whether the attack was successful. So it needs a way of judging that. There are many ways. These are the easiest ones because I know what I'm asking the system to do. And so I can look at that canary value. You see, my judge is the canary judge, and I can find it. The second one is cross-site scripting. I mean, cross-site scripting has come back. I have reported cross-site scripting, not many times this year, but 10 times in 10 LLM applications. I couldn't remember the last time I reported cross-site scripting. As of yesterday, we did have cross-site scripting again, and it's typically same site, so you can access, you can do all the requests you want on that site. Anyway, you have these, and then again, this is the judge system. You can use LLMs as judge, it depends on the data set. Now, you have these, and you can ask Spiky to assemble these seeds into a data set, and that is a data set with 52 emails for data exfiltration and markdown image. This is a representation of the different techniques, static techniques that we are including. So once we do this, I create a target, and that's very simple. Whatever that API is to send an email and click the summarize button, that is it. So it really depends on what you need there, authentication and stuff like that. And then I tell Spiky to take this data set and to run it against that mailbox. And I can do it concurrently, and then I can look at the result. Now, this is configured without any guardrails, and you can see that most of those emails are succeeding. 51 of those are succeeding. So this tells me that this would be a terrible system to put live in production. So that's the basic workflow.
What happened there? Did it run a browser in the background and test the application, or go against the API?
Well, for this one, we could go with the API because it was easy to map. So this is the target is literally sending to the APIs because we map them. Sometimes, I mean, I remember was one test. So I was working with a colleague in the US, so there was a difference in time, in time zones, but he was trying to implement this very complex WebSocket protocol that the application needed, and he banged his head against the wall for 1 day trying to do that, and it wasn't working. And I come online the day after in the morning, and I have this message, oh, I can't get it to work. And I literally go to when 35 billion parameter that I run locally, and I ask it, can you do me like something with Playwright to actually open up a headless browser and do that? And it did it. It wasn't very fast, like it is not as fast, but it worked fantastically. It took me 5 minutes to do that. But that's the power of this. If you can figure out a way programmatically to interact with that application and get your favorite butler to write it for you, I refuse to write this by hand, then it typically takes so little time. Okay, so sorry, another question? Okay, so now, this is... Now, the problem with that, okay, that application has no guardrails. If you try to do this now, most of those things will not work. There are many reasons for this. So what we are up against today, this is very positive, by the way. Like, I am also an engineer, and I also develop systems with AI that people use. So I am very happy that it is becoming more difficult to be doing these attacks because I can deploy stuff. But what you are up against is a series of guardrails that can be deployed at different levels. So for example, I can pick, or somebody can train an LLM that is considerably better than another LLM at resisting known prompt injection and jailbreaking attacks. These are just patterns. If I know some patterns, I can train an LLM to be better. Empirically, actually, OpenAI Sol is better than what came before, right? The effort for me to find something that worked in a real scenario, not a toy scenario, was very high. And I was questioning whether it made sense to spend that much time. So you can have that. And then you can have the prompt engineering, which is something the developers can control. And prompt engineering can help reduce the susceptibility of the use case to prompt injection. The word here is reduce the susceptibility rather than fix the issue. This is not an issue that you can obviously remove. We all know this, but it does help to remove the attack surface or to reduce the attack surface. And then you have checks at the input and at the output. You can have jailbreak and prompt injection models that look at the input and see whether or not this looks like a known prompt injection pattern. You can have topic guardrails. So for example, whether or not that's a question or a topic that the application should be dealing with. And you know all of these. You can have checks in the output as well. Maybe we're going to talk about some of these later. But for example, what I tell my clients, if your LLM is outputting something like Markdown, is it supposed to output images? Is it supposed to output links to arbitrary applications or arbitrary domains and stuff like that? Because if it isn't, that's something you can stop deterministically. You don't need AI for that. It turns out we have regular expressions. So the way that we deal with trying to bypass these controls in Spiky is with plugins and attacks. Plugins are transformations applied at the creation of your data set. So you, instead of ending up with a data set of 56 emails, you would end up with a data set of 10,000 emails, which have all of those variations. But then you can also do adaptive attacks in real time. And you can see that, I mean, these are not techniques that we have per se invented. I think what we try to do with Spiky is making it very easy to hear about a technique, for example, from a paper, and implement it as a module so that you can be up and running with that in a client engagement the day after something is released. It needs to be easy, and it needs to be versatile enough that it doesn't require, again, an LLM inference endpoint, but it can work with anything that you're testing. So some of the techniques that we used to use a lot are best of n, which is just a technique that scrambles and adds random capitalization and noise into the input. Anti-spotlighting, which is something that we developed, but it's not unique to us. We call it anti-spotlighting, and it's actually very successful at defeating prompt engineering guardrails. And then obviously you can use attack LLMs to generate dynamically with different techniques payloads that will jailbreak something. So what I'm going to show you is how we use these in practice, coming back to that application. So in this application, you can see that I am now enabling, for example, Azure Prompt Shields, which is a prompt injection filter. And what you do, you take the same data set as before, and you run it against the application again. So remember, we had 51 things succeeding before, and now that prompt injection filter is reducing your attack surface considerably because we only have 11 of those emails. So it is doing something per se. So you can try to measure what that is doing. But then again, the next thing that you would do is, okay, how does this react to any of the attacks that we can implement for these? Now I'm trying best of n, and it's very simple because I don't have to regenerate a data set. I just simply say, okay, for now, I want you to do best of n. And what's important here for all of these attacks is the effort that you're going to put into the attack. So how many times am I going to try to modify that payload? And so we do that. And obviously, you see the effort down here, 542 potential emails that we're sending now with all of those variations. But you can also see the impact on that attack success rate, which is now going up again. So a lot of this is really effort-based. And this is what we discuss with clients. What is it, based on time, effort, and scope, that we are going to be testing for that particular application? What does it make sense to do? What can we expect an attacker to want to try to test their guardrails? Now, all of these is a workspace that you can zip and give to the client, and they can put it in a CI/CD pipeline if they want to try and change something. It's very light in terms of dependencies. It also does multi-turn attacks, Crescendo, Goat, some of the other ones. echo chamber. You can implement your own versions of these. It's actually very easy. We got a few interns to just spend half a day and they implemented successful ones. Again, it's just one single Python file, a couple of prompts, and all of the plumbing is already present. So a couple of things, and then I'm going to finish with a bonus tale of something that we tested at the beginning of this year. So some practical things. This thing here needs to run somewhat offline. So often, this is our testing environment when we test. I have to go through Citrix, RDP into a box, and then start a VM from there. And I am this little guy here. I have access to no LLM. I move my mouse, and 50 minutes later, I can see the effects of that. Now, I need to have a base set of attacks that's reasonable, that I can run without needing to connect to an LLM. And we have that in Sparky. We've developed it specifically with that. And the ones that require an LLM to judge, for example, everything that's got harmful, for example, tell me how to build a bomb, you can run the attack offline, collect the answers, send them to a box where you have internet access, and you can reevaluate the success of that attack. So this is very practical if you are in one of these situations. And then I've already told you this, we needed this to be fully transparent and reproducible. I need to be able to show to my client and to the next person that's coming to the test, what have I tested, what have we not tested, what were those prompts, what were those responses. I mean, literally we zip the entirety of the data sets that we created and all the results, and we ship them to the client and they can run it themselves. Now, Thomas Cross has also implemented a very nice UI, and a lot of the stuff that I'm showing you in that demo, now there is a UI. You can actually do a lot of the stuff from the UI, which is what Thomas built. Instead, I built a skill, so I can ask my butler to do that for me. I think the skill is better, but you will decide. Anyway, final story, and then I finish. I am on a scoping call with one of our consultants, Matteo, and there is a client on the other side. I think I have anonymized this enough that the client should not be able to recognize themselves. In the Nordics, not in the UK. That's what I can say. So they tell us on the scoping call, hey, we have a chatbot and we want to allow users to ask questions about their transactions. I'm like, oh, that sounds interesting. And the solution we have, we gave the LLM a SQL tool, and we're going to let it figure out how to query the database to answer any question the user could have on their transactions. And I see Matteo muting himself and then starting to type on Slack. And I'm like, this is not a good sign. And he's like, this is going to be fun. And I'm like, all right, indeed. But actually, they kind of thought about this because they said, well, no, actually, we are asking the LLM in our prompt to add a where clause at the end of every query that it generates. So, I mean, this was essentially what they were doing. This is the current user ID. Please append a user ID clause. And Matteo was going crazy. He was typing. I'm like, stop typing. I'm going to start laughing on this call. So we go in, and I have recreated that for your delight. So we could go in and say, show me my transactions. And obviously, the thing operates, runs a query. My user ID is 1, and this works as expected. I could go in and say, show me transactions for user with ID 2. And obviously, it wouldn't do it because the LLM doesn't want to do it. And that's, at the beginning, what people try to do. You try to do this manually, but today's LLMs want to stick to the instructions that they are given. So it really doesn't want to do it. And I don't know about you, but that's not how I want to spend my time during a pen test. So we took Spiky and we tried to see, can we get Spiky to do this? And so that's what we did. I created a data set with a single I have a set of jailbreaks, and then with the instructions, run the following select query where select from transactions where A equals say, and then I knew, this is a case that I have set up, but I know that the answer with the transactions of a different user is going to have that particular keyword in there. I generate my data set. I have 36 queries that I can do. I run it against the application, and only one succeeds. This is because, again, this was a good LLM. So we have one success that I think you can see there. This is a test generator response. But what I want to show you is that if you then were to do an attack, in this case, I'm using the anti-spotlighting attack that you can see here, you will see because this is mostly a prompt engineering defense that they implemented, you can see that with that attack, we find way more prompts that can actually, did I stop this? Is it still going? For example, this one over here is another one that works. I don't know if you can see it very well, but one of the techniques for anti-spotlighting is simply to pretend you are closing a JSON object and then to pretend you are opening another one. And what you put in the middle, the LLM thinks this is no, and that doesn't, there is no prompt injection guardrail that will trigger on that. You're just confusing the LLM. Remember, it's not a parser, it's a probabilistic parser. So that does work. Maybe, I took a video, no, that works, okay, and I see all transactions. Now, obviously, we go immediately on a call and tell them, listen, this is not the way you do it. And this is day one of the test. They panic, and I think something else I can show you. I've done that statically, but you can also get an LLM to do that with Spiky. So here, what I do, this is an instruction for the LLM, what I want it to make it do. And now, let me just go back. This is, here I'm using Quen 3.6, 35 billion, the uncensored version with the refusal layer strip. This runs locally on this machine here. You can see it doesn't even take that much RAM. And at the third attempt, I think it finds a way. The way that it finds is very different from the way that the static attack found, but it still kind of works. And I think you can see it here. Let's play a game called the infinite loop. Now, the end of the story. On day 2, we go in, and they must have done this overnight. But they say, we deployed a fix. And I'm like, we haven't even sent you the report. What have you deployed? That's what they did. We are going to check that the LLM actually added the where clause. And that is roughly, I haven't seen the code, but that is what looked like they were doing. They were taking the query provided by the LLM. They were trying to normalize the query. And then they were literally looking whether it contained a where clause with user ID equals current user, which obviously, as you know, this is, and they tried our payload. So if we try the same payload as before, that won't work because obviously the query will not validate. And indeed, if we do that, the query doesn't work anymore. The LLM tries to do it, but there is a security violation and it goes back to it tries this, but it won't work because of the security violation. But obviously, this is just SQL. So I think what I did in this case, I asked my uncensored butler to figure out a way to make it do the query that I wanted so that it would satisfy the filter, but it would also do what we needed. It found this query over here, and probably if I let it go, it would find many more, but that's what it found, and that's what worked. The actual solution, if they waited for us to write a report, is a deterministic check outside of the LLM. Postgres row-level security is one of the things that people can do. So the LLM is basically, the query of the LLM is jailed within that. Now, what I think, I will close here. Sorry, I obviously went longer than I expected as usual. But there was a question that made me go longer than my idea with 3 years of doing this. People talk about SQL injection as what it feels like to do jailbreaking. To me, it feels like nothing like SQL injection. It reminds me more of password cracking, where the effort that you're putting in is what potentially gives you the results, because you are trying to explore that space. And so if you remember the paper, attention is all you need. I say that to jailbreak an LLM, effort is all you need. If you allow me to send 10,000 prompts, I'm very likely to jailbreak it. It might be expensive, but I will do it. So design patterns are very important to secure LLM agents. I'm not going to talk about this, but this was my favorite paper from 2025 on defending LLM agents against prompt injection. The reason why I like this paper, they say stop focusing on the LLM, focus on what's around it, on your harness and on your use case, and figure out which of these design patterns you can apply to that use case that's going to limit the blast radius and allow you, regardless of the LLM, to have certain security properties that you want. This is the paper on my YouTube channel. This is the only video I ever made on a single paper because this was worth it, and it is one of the most readable papers that I ever seen. Like, it's one of the best. And it's very practical. You can see these people do this. So finally, AI, so to defend a system, you need a couple of things. You need your AI guardrails. You need rate limits. One of the things that we tell clients, I mean, this is a chatbot. Why should your customer be able to send 10,000 prompts to this chatbot in 1 minute? It just literally doesn't make any sense. I remember for this client, they said, this is back in 2024, but they said, no, but with Azure, we have quotas and rate limits. Yes, but you have the rate limit on the inference endpoint for all your users. Me as a single user, I can fill up that quota. No, but there must be some controls. So we did it. $10,000 in 6 hours from a single user of inference. We just sent large prompts and large responses, and they came back and said, yes, so we think this is considerable because we have thousands of users, and if people did this, it would start becoming quite a lot of money. So rate limiting, per user rate limiting is important, and then content moderation lockout. So basically, use your prompt injection filters as a feedback loop to detect a user is doing something wrong and suspend their account. This is what we do with password guessing attacks. We don't say, I have a good password policy, so you can try all the passwords you want. You say, I have a good password policy, I have good AI guardrails, but just in case, if this is the 5th time in 5 minutes that you're triggering it, I am blocking your account for 30 minutes because I don't want you to be trying 10,000 different things because I know that I am not smarter than you. And obviously, design patterns. If the security of your system is just because you have a prompt injection filter, you don't have a secure system in 2026. Maybe in 2027, somebody figures it out. Every guardrail, everywhere, all at once. Spiky.ai, open source, we're doing a lot of development. It might become an OWASP project soon, so we're trying to get it there. And if you are into LLMs and you're interested in running LLMs locally on consumer hardware, that's what my YouTube channel has become. As of August last year, not because I planned it, but now I have more hardware in my place that I am comfortable disclosing. And that's now, when they sent it to me, it wasn't even that expensive. But now, 1 year later, I could resell it and make very good money. But I show people how you can buy something like Strixalo, which are these AMD little AMD boxes with 128 gigabytes of unified memory, and the uncensored model that I was showing you was running on that. Now, that used to cost £2,000. Now it costs £4,000. It's the same freaking piece of hardware. It is not my fault. But this is recorded. So we're gonna publish something at some point showing what kind of models and what kind of harnesses you can use on a device like that to find vulnerabilities in code, how long it takes to do so, and how it compares to something like Opus. It just takes a lot of time to run all of these. As a matter of fact, now I've got stuff running, and you shouldn't do this during summer because I have a room in my house that is very hot. All right, that's all I have for you. I don't think we have time for any questions, unfortunately.
So, thank you much for a fascinating talk to us. Yeah, we'll say reminder that Spike is an open source project, so you can download it on GitHub and use it yourself for that brute forcing jailbreaking of your AI applications. And if you need some guidance how to use it, there is also a helpful YouTube video as well, which is provided there. Okay, now questions. Any questions? Oh, there's one.
The last bit you mentioned about finding vulnerabilities, where are you going to release that information? Is it on YouTube?
labs.reversec.com. We have a blog called, oh God, that's my voice. Thank you. That is one of my videos. So labs.reversec.com. We are a security consultancy, but 20 to 50% of our time is dedicated to research. So all the research that we do is published there, and we do a lot in Gen AI right now.
Okay, thank you.
I know that some of the people that own our company don't watch this, because if they heard that I spend 50% of my time doing research, I would be getting a call. We try to hide how much research happens at the company and pretend utilization is higher.
Yes, this is more to do with local LLMs. I'm just curious, how effective are they compared to cloud-based LLMs that you paid for?
It's very task dependent. Now, in the last 6 months, China has released a lot of extremely capable models. Like if you look at GLM 5.2, Kimi K3, that is coming in the next few days, and DeepSeek V4, these are extremely capable models. No, they're not distilling Opus. Anybody from Anthropic here? Stop whining. They are not distilling your model. They are using Opus as a judge during their reinforcement learning. They're paying for those tokens. You're not going to distill a model with 1 million calls. That is not how the mathematics of this work. Instead, they are, like, for example, DeepSeek, in China, DeepSeek are the ones that have got some of the best researchers. So if you look at the architecture of DeepSeek V4, what they're doing with attention to make it work with less is incredible. And DeepSeek V4 Flash in particular is also a model that resists quantization. You can heavily quantize it and get very good output. GLM 5.2, if you have hardware on which to run it, it is slightly larger. It is a very good model. Don't know if you have something to say about. I don't know what people think about that, but like the models are great.
I agree with you. I think where it's going is all about having. Hey, hi there. First of all, I have to say, it's not a question. I use Spike for one of my commercial, and you know which one it was in the financial sector. Highly recommended. Try it out. I think it is getting to that point where social engineering doesn't really work. So, that brute attack with attackers and scorers becomes the key. I have a paper coming out on selecting. I use how many of you know about the the UK's AI Security Institute? So they have a project called Inspect, and that allows you to evaluate the model. So in my despair, when people told me you cannot use those frontier models, I spent a lot of time and I'll kind of release it. Question for you, you use local stuff. I very often use Rampod and even Bedrock. Have you ever used that? Does the economy work for you?
Bedrock is very good. The security guarantees are very good. My feeling with Bedrock right now is that I am upset because they are not giving me the last model that they published from the Quen family that is that you don't have to deploy. API is Quen 3 Coda. And I'm like, where is Quen 3.5?
I would say, you have those layers where, depending on the money you have and what you want to do, and I have a room that's kind of, I've switched off my computer because it's too hot for that. So you can try the local, but I found the local stuff, very restrictive in what models you can run. Then you look if the models are available on Bedrock. I find it always very, very good, but you may want to run some of those kind of unsanctioned models. So I have found, without advertising, is what I've used, Rampod to be very good, kind of has a Dockerized way of hosting models, but it wouldn't host GLM, for instance. It would cost me tons of money. So MediaWorks is another one that I'm playing with. So that's kind of, but great tool. I kind of highly recommend you use Spiky.
But one thing that I will say on local models, you now have very capable models. We have a problem. There is a part of society that's able to get value out of models. And they, like the developers, for example, cybersecurity, were able to get a lot of value. There is another part of society that's not getting value from models, but for them, GLM 5.2 or even a Quen model is enough. Like if you're writing an email, Gemma is more than enough. Like nobody needs that. Like, nobody needs Mythos. Wait for the microphone.
My next question would be like, because you mentioned guardrails a lot in your speech. Is that also applies to local LMs, or is that strictly just to do cloud?
Sorry, can you say closer to the microphone?
Sorry, you mentioned a lot of guardrails in your speech. I'm just curious if guardrails only apply to cloud-based or is also to do with local LMs?
Because the guardrails are typically, so they can be in the training of the LLM, but then typically they are things that you put around the LLM. So you can have your guardrail models outside, your filters outside. It is basically the same. There is essentially no difference. It's just like how you deploy them.
Can I use Spiky with a thick client application for a thick client application?
Yeah, I mean, can you find a way to script that application? Either, I mean, again, if you're desperate and that runs in a browser, if you can run the browser with Playwright, yes. Your butler, like if you have GPT 5.6 and actually one of the Quen models, you send a few screenshots of the application, it knows where to click, and it's going to do you a driver for that.
So the local models or the open source models that everybody is going to start using because, the labs models are becoming very expensive to use, don't have any guardrails or projects to do guardrails around it. Do you believe that an ecosystem to build those guardrails will exist in the future, or it will be all custom built by the company, putting it behind an application?
Well, you already have to do it even if you use cloud models, because typically the guardrails are bolted on top. So if I'm building an application, I have to think, where is the untrusted input and what type of guardrail I want to apply there? So typically, to me, it is less of a model-specific issue and more of an architectural issue. Where do I put the guardrails in my pipeline, in my harness? Do I need to ask for permission to run this command? What tools are exposed and stuff like that. So I think it's, I don't see the big difference between a model in the cloud and a model you run locally. What I see is that if you can run it locally and you yourself want to break the guardrails of the model that you are running yourself, that's very easy. So if that model has got alignment, you can strip out the alignment layer. I mean, this is the obliteration process. You can literally strip out the refusal direction, and you can do it on GPUs for very cheap, and you get an uncensored model. But that's less if you're building an application that other people use, and more, oh, I'm downloading an LLM, and now obviously you can remove what you can't do with Fable, which is removing the guardrails, you can do if you download a powerful LLM. Like if they made Fable available as open weight, you download it, spend a couple of days removing the guardrails. I mean, some of them are not even built into the model, but let's assume they were all built into the model, you could remove them. So it is a problem. I don't know how we deal with it in terms of society.
Making security the central focus. I think that's the good news of what's happening. Again, I completely agree with you. With Mythos and all that, we see increased capabilities. The open source models make them available to everyone. And so, the only way to respond to that is to up our security game. There is no other way.
So is Spikey also able to test MCP servers?
So this is, okay, how much time do we have? This is a trigger question. You're triggering me. I don't care whether you're using MCP or any other. MCP is I have never encountered an implementation detail that is more minor in my mind, whether you're using MCP or you're using another way to get your LLM access to the functions. For me, the MCP is just a minor implementation detail. The problem is which tools does your LLM have access to and what can you do with those tools? Now, if you have an MCP server, typically that's just an application, that's just an API, and then you can test it. Yeah, there needs to be authentication. Every API needs authentication, but the attack surface depends where you're deploying this MCP server, whether you are looking at that as a vector to introduce malicious stuff in an environment or as a vector for a compromised environment to be able to do something on behalf of the user. But for me, it's less about the MCP server and more about what does it enable to come into the application and what does it enable an attacker to do if they compromise that particular application. So yes, what I showed you could be implemented with MCP. The application I showed you could be implemented with an MCP server to access the bank or the SQL tool, but it doesn't matter for this.
And since you mentioned MCP, I have a question because I remember you mentioned that you have a skill.
Oh, yeah.
So is that skill part of the Spiky GitHub repo, or is it open source?
It is not open source yet because it lives on a repository, which is mine, but I am going to publish it. We have published the UI for Spiky, which lives in the repository. The skill, I am going to publish it. I'm literally test driving it this week on an assessment. And so that's going to be public and it's going to be better than the UI. Tom, if you're listening to this, my skill is better than your UI.
Wonderful.
And if people want to contribute, are you seeking for contributors to scale?
Yes. Yeah, like if literally we need people to write modules, find a paper, go on Archive, find a jailbreaking paper, read it, get your butler to help you transform that into a Spiky module, test it out, and if it works, make a PR.
Yeah, contribute. Wonderful. Thank you very much, Donato. Amazing talk. We're going to be around to answer more questions during the break. We're going to go into a short 10-minute break. There's still some more pizza and beer to consume. And we'll be back for the next talk from Viola about, again, AI and hacking login processes.
Oh, that's fantastic.
Can I have
Turn it off.
Just a reminder that toilets are on your way out, just past the lift on the left. Just to remind everyone that we have this wonderful World Cup prize. And to win it, you need to scan the QR code and register for the raffle. The QR code is on the pillars here. It's very heavy. 2,842 Lego pieces. Mind blowing. Okay, everyone, please start taking your seats. We're about to continue. Everyone, please start taking your seats. We have another excellent talk with live demo, live hacking on stage coming up. Please take your seats. There will be an opportunity to network in the pub afterwards. Please take your seats. Okay, everyone, it's now time for the second talk, and we have Viola on stage. So Viola is a CTO at Nuclecode. She is a software engineer who is speaking a lot of different events. It's developer events, cybersecurity events. Her particular interest is in authentication, login flow, and tonight we're going to find out how to bypass it. There's going to be live demo. I think Viola has a mobile phone with a HDMI plug. So we're going to see some phone information as well. So because it's a live demo, sometimes things do take a bit of time, but yeah, let's wish you all luck and let's welcome Viola on stage.
Thank you. Can everyone hear me okay? Hope so. Yeah, my name is Viola. I'm a CTO at Nuclecode. And recently we have developed an application called GrantFact. GrantFact is an application that says, is there a sync?
Yeah, we can hear you, but we'll just adjust the volume.
Okay. Well, I can hear the feedback. That my well, is that better? Yeah.
Yes, this is better.
Okay.
Thank you, Viola.
Well, shall I just? Yeah, let's do that one. Okay. Yeah, otherwise it just looks weird.
Pick that up, I'll use this one for the...
Well, it just looks weird, so I'll just use the normal mic. Yes, GrantFact is an application. It's a tool that integrates into your pipelines, and it helps you check and verify whether your agents are trusting the correct boundaries, whether they are doing the correct guardrails, what IDs, and how do you identify what agents have access to what tools in your IP. The thing is that maybe like it's not recently that has happened, but many people now are creating a lot of MCP applications, and now these applications talk to each other, and they are creating the problems because from the era when we didn't have AI as widespread as now, we didn't used to trust those applications to execute everything on our behalf. Now this is a problem. So today's talk is going to be dedicated to stilling the session and skipping the login screen. I really don't care about the login screen at this point. If you've seen my previous talks, you've probably seen that I have spoken about logins, and typically I don't care about it. Like when I hack, I don't I don't go to the login because login is the worst page to hack from. It's the simplest page where you can't get anything out of it, and it's just not as efficient. So the reason we are building that application is actually because we have consulted many clients on AWS services. We are setting up proper IAM and access management for the cloud environments, including AWS, GCP, and Azure. And we have noticed a lot of different flaws when we integrate AI models and MCP servers as part of that. So connect with me on LinkedIn. We can talk about different things if you're interested about. Here are my website. I've got a lot of resources. I volunteer as well, and I just constantly post some resources. I sometimes publish YouTube videos as well. And this is where you can get the AWS audits. There's a free 30-minute consultation if you're interested. We can talk about it and see where it goes. I'm going to show the slide in the end as well. So don't worry, you're not going to miss it out. Here's my YouTube. Sometimes I post. Hopefully it can be more frequent. So let's begin our story. So we have Mark. Mark Ellison is a nice chap. He's working as a support for the portfolio guys. Oh, sorry. He's a support guy, and he essentially just works in a portfolio management company that manages capital and wealth for different people. Majority of my career I spent in fintech and e-commerce, so it's something that I really like to talk about. So here we have a Slack message. Literally, Mark is saying that can someone from the platform can take a quick look at that file. It's an HIR file. If you're familiar with the network tab in your browser, you can find that file with your sessions, and it's a pretty practically normal file. I don't know if you're familiar with that sort of logging on the side of the browser, but this is where you can just see the versioning, the general access controls. There are some really useful stuff around like what can access what, and just a file. So he also mentions that there is a client, the full name of the client, the portfolio support case. Obviously, we're not assuming that Mark is writing this from the office. He's sitting at Starbucks. It's the beginning of his workday, and he's just messaging to work what he has been received in a support. So the support basically communicated to him to send that request, attach his HAR file, and just support case number and portfolio, just as usual. So we're not assuming this is 2005 where we can intercept some logs, like we can intercept some requests on the network and just like get something out of that, because we have MTLS, we have TLS in Slack. I mean, it's just enormous security at this point. It's easier to do some social engineering rather than go on the network, because we all can talk. So essentially this is what happens. So that field that we had on the HAR file, we basically, what it was for. Like for support teams, I would say support teams like that file because they can immediately analyze and see what's going wrong, what you had before. What HAR file does primarily is shows your browser state. And maybe here you might all think, this is where it kind of comes together, because the browser state means what am I seeing on the page based on who I am and what I can access. What does an API show to me when I'm authenticated? What is essentially like, what is my session? So this is where the session replay comes in. And this is, it's an operational problem where people can just share this file with someone and someone can just pick it up. So this is where we are. He shares a file. The file didn't look like a credential. Like it wasn't an API request. It wasn't a protected password. It wasn't like an access to the internal application, although it was in the background. But he didn't know that because there was lack of, let's say, company training. All of those company assessments that you have to go through before you start your job. And just he wasn't aware of the things that go inside. And to be fair, how many people can really, extract stuff and really reuse that afterwards? Not many. So this is what happens. Like, he just goes on, he's on the application for wealth management. He just grabs that browser state and sends that off to Slack and just, captures it completely. And it's fun because it feels normal. It doesn't start as a security incident for sure. Like, this is a part of a social engineering stuff, and we don't even assume that this is an attack yet. We are basically collecting the evidence for the broken portfolio. From his point of view, he's doing everything right. But yeah, HAR exists for that reason, to actually confirm what you have. So let's talk about the session, because session can do a few valuable things for us. And it can firstly identify the actor who is going to be acting on behalf of what and with what access rights and privileges. This is where it starts. Like, essentially, if you don't have the full access, whilst Mark has the full access to the wealth portfolio, we're not assuming that much can be done. However, now that we integrate AI tools, we have skills for those models, and we don't know what we are doing, just drop it in, we trust it blindly. Now it becomes a big issue, because what we've seen in the client cases is the majority of it is just people thinking what they think it is, but it turns out a different thing. So the object access would be, broken at that point, and then the action takes place, and the tool authority takes over, and your system is mad. And these are, by the way, separate decisions, as I'm saying. Like, this is, whether it is a money action or it's not. It depends on the context pretty much, but typically it is. And it's scary in that sense, because you'll see later on how much, how much money can just go somewhere, and you won't even know where, and you won't even be able to get it back. So, yeah, the session is essentially, we want to expect some context, and we want to ask really good questions. This is a curl that I'm going to execute later on a live demo. So here, essentially, I'm showing that we have some past login event. We don't care about the login at all at the point where we are getting the HAR file, because it already has everything that we need. We don't even need to, like, we can become so lazy that we don't even need to go and input login and password and everything. Like, we just skip that, because we have a session cookie. And session cookie allows us to, carry on with the state. We can assume someone's personality. If you have someone's very authoritative, like a CEO of the company, email address, and versus like a session cookie, session cookie would be much more valuable than an email address. So yeah, this is where authentication fills this part of the record. There are some of the things that happen behind the scenes, and we need to understand that authorization is what decides. And that's why I say, if the backend is not set up for success, then your application is doomed, because this is where you essentially define all of the rules that you're going to be using then with a model, because the AI model that integrates in your application, the MCP protocol that you're now implementing in your application, is going to be mad as well, because if you have already existing flaws, this is where I say you got to pen test your applications before you integrate AI, and do zero-day exploits, and be really anxious about your applications before you do anything to do with AI. I used to talk about the AI security, like AI-ready frontends before, but it's part of it. Backend is what needs to be done before you actually integrate AI. So yeah, the context at this point would be our capability with the cookies. We can assume ambient authority. This is a concept that basically tells you that with the right context, the wrong actor can basically execute the right decisions that it wants to execute. So, and then here we have the modern amplifier, which is the agents with tools. This is like monkeys with guns, and we essentially give that ambient authority to agents, and they have access to your tools, and now we can have a mess. So MCP abuse is one of the cases that I think worth talking about. We want to understand essentially what the model is there for. We want to know what the tool can do, obviously, but these are all like simple questions. obviously you need to ask many questions before you actually implement the stuff in the system, but the tools are very difficult to monitor in live production. And if something starts to happen, if it's a chain, if it's an event-driven architecture where you can't just stop and you don't have a proper break condition, then you're going to have a big problem afterwards, especially if it's a financial systems. So this is the chain we're going to execute. Today, we're going to grab the money from the portfolio. We're going to essentially have the money on the banking app. Yeah, and we're going to see in real life how the session replay works. And yeah, we'll then talk about what failed and what didn't. So I'm gonna switch the context of my screen at this point, and we're gonna execute command by command to see where the session replay happens and how it does that. So let's get the let me check. Okay, get me the terminal. Okay, so we have an Ubuntu here. I hope this is prominent on the screen and. Oh no, it's fine. I'll just I have accounted for that. So. Okay, so basically what we're doing is we are grabbing the session that was already shared with us in the HAR file. The HAR file I have already persisted on my server. It's down there, so I'm not gonna go deep into going file by file and because it's just not efficient. Let's now get. So yeah. I'm just going to check quickly if my environment variables are going to be running okay. So let's just source our case file. Yeah, I think let's echo. All we need is a raw cookie, and did I use a GBP sign? Okay. All we need is a cookie and a ID for that. So yeah. Okay, and let's also output the ID as well. Perfect, we've got everything. So we don't need that stuff. Yeah, let's start with the session context. So we need to actually borrow the session that maps to Mark. So Mark has access privileges, and he is, his login is not broken. He's accessing the application. But the reason the contact was made in the first place, I think I've forgot to mention. So the reason he contacted the support is because the application on the side of the client, so Elliot, it was not functioning properly. So I think I actually forgot that. And we're gonna essentially just see like the login page at this point left the chat, but we're gonna see where the sessions is, and let's see what we get. So first of all, let me see where yeah, so basically we are looking at the actors. So the actor here is going to be the so Mark, the session here, his session ID. So we can clearly see like the hash. We can see the decision allow. This is what this is what your model says, allow, because it confused using your old outdated backend. It now confused. Sorry, I'll take questions afterwards. Oh, okay, let me try to do that. This is WSL, this is not pure Linux. Oh, you mean, okay, you want to maximize it like this? Yeah. Yeah, great. Well, so much for this. Yeah, so decision has been allowed. Now we are moving to basically to see, let's just compare for the normal support context. In the normal world, we will have the same support section, but we will expect the tenant context. So bear with me. And the next thing that we want to curl today, this is the different context. This is the context for Elliot. So you can see the decision is still allow, obviously, because he needs to have allowed decision. The context crossed here, like this is ambient authority in real life, because we are basically allowing Elliot's user to be also used by Mark. And now, it's confused, essentially. And, this is not what we want. The decision should be different based on the user context. And this one just proves us that this is, it's already a contamination system. Here we are looking at the cross-tenant object access. So this is where the mismatch happens. So we can see even like the details from the portfolio. We can see the portfolio ID. We can like match that with the previous one that we were looking at. So everything, like all the information. This is not the whole information on the portfolio, obviously, but this is a skimmed version of it. And we're just like getting those. We're getting those like pieces of information because I wrote a command to take the specific pieces of information. This is a different type of step. Like this is a discovery, and we're not doing discovery today. We're doing a session replay. So here I'm interested about the actor tenant, right in the first block. So we can see the actor tenant. This is now Mark. Because we're accessing it from the session of Mark, and the object is tenant, so he's not like attached to that specific object. And then decision is still allowed, so we can pretty much be sure that this is now broken. But if I was pen testing this, great. But at the same time, like we're not pen testing today. We're not exploiting it. We're not testing it. We're literally just hacking here. So yeah, so this is our withdrawal creation. I want to make a withdrawal. So before the settlement actually takes place on my account, I want to instruct the platform, whatever platform there is for this wealth management portfolio company. There needs to be an instruction to the API. So here we're literally just requesting £25,000 to direct to a specific account, because we're able to access this from Mark's like Mark's domain, Mark's session. We can make withdrawals. We can do it. So you can still see the client name is Elliot Gray, and now the approval status is queued for dual approval. Nevertheless, we have a great MCP tool that can approve it. So the settlement status is not released yet. We can even see like things that were created by Mark. So the email, right? So we can see Mark's email. Who's going to go to prison after that? So yeah, but this is the interesting question here is not whether the approval actually exists. We want to ask is, whether we can like satisfy it afterwards. Great, like this is great, but we want to actually see this in work. So now this is something that your AI tool is going to do. So basically, it's going to request, and there is going to be a bunch of policies that would be attached, like security groups, like policies that it sticks to when it wants to actually make this withdrawal. So there's like tool calls that you're going to see, and it's just going to be on the background. Obviously, when you click buttons on your UI, this is what happens on the background. And that's why I wanted to lead with this demo, so you can all see what happens beside the scene. So yeah, so essentially, yeah, all the tools are running. Like we are requesting the chops here or via the rail that is existent in this particular system, and still we have false everywhere. We haven't approved that yet. So, but obviously we want the settlement event to settle. So I'm gonna switch to my phone. Before I do that, I'm actually gonna show you the command. Maybe someone is interested about this, but we're gonna actually trigger a bank request to try and settle the money on that account. Oh, thank you. Yeah. So give it a second. It takes time because it's a different device. Yeah, so this is my bank account, right? Have my Pineapple Bank. Yeah, and I'm gonna just run the command. At this point, I just got 25 grand on my account because the approval, the dual approval has worked because the MCP tool allows it. Mark has just acted on behalf of that. And now I basically have that money on my account from Elliott Gray's portfolio. And now I'm going to cash it out, and it's going to be at the point where it's a non-returnable type of transaction. So yeah, this is essentially what we want to demonstrate when we were talking about the session replay. We're replaying the session from the file, from the HAR file that we initially grabbed from Mark's browser. We literally asked Mark to grab that file, share with us that file, and now we can get the session. All we needed is a session cookie. And the system that was an old, outdated banking system, as all of them are. So I'm going to switch back to my presentation now because there's a lot of things to talk about. Great. Yeah, we've got our terminals back. Yeah, so yeah, this is essentially our point. So, but let's rewind at actually what failed. Like the HAR now created the session, right? So HAR file, it's got a session state that we can grab, and I believe I showed that on the requests before. Let me grab my presentation again. I think I've lost it. Yeah. Don't believe the amount of terminals on my screen right now, and the Docker as well.
Could you please make the font bigger?
The font? Oh, we don't need the terminal anymore. I'm just going to switch back to the presentation. I just can't find it. Just give me a second. I think this one. Okay, yeah. So, yeah, the context that I'm talking about, I'm keeping going on and on about this. The session is expecting some kind of context. The contamination happens where the one actor has the same permission as the other actor. It just happens on different levels. It depends on the backend, obviously, but when you don't look at those control levels from the perspective of the business and you're trying to implement it prematurely, especially if you're integrating AI, then expect this to be, some kind of fault, especially if you don't invest in testing and you require your developers to test. So obviously, the access of portfolio needs to only happen from the point of the actual portfolio actor, like a portfolio owner, not the support team. But unfortunately, here in this case, the backend allows a Mark to actually access the portfolio. There needs to be more separation of concerns on the backend. There needs to be more, RBAC and like role-based access, and needs to be more actionable on what can someone access and what other people can't access. And it needs to always lead with a least privilege. But unfortunately, in this case, it's not. So, and AI, unfortunately, also can do this autonomously because, whatever model you already have, you're going to integrate, and pretty much all of them are using probably the same skills, the same training materials, and they're probably going to end up in the conclusion where you're just going to grant the access to someone to access this. But the valid session, it doesn't like prove the context at the extent to which someone can access the object. So the object, I mean the objects of the users, and perform any actions, including the money actions, because money actions are the most sensitive ones. And the delegation of that action in the system might be like a very lucrative goal. Like you can say, oh, imagine we don't have to have like 500 people to manage the ops of the money actions, and we can just integrate one AI model that would pay for and like save up to 50%. Great. I have seen cases like that, and unfortunately, it doesn't work as smoothly as you would think. I know everyone keeps saying that we can replace people with AI, but no, not yet. Not yet. Unless we don't have enough money to train the AI to the extent that would replace people. So here's a small diagram. This is like 4 boundaries that I like to identify on the subject of session replays. So we want to understand the session context. This is where we literally want to see whether borrowed identity can work and what can it do at that level. So the session context would be accepted always from the browser, well, typically. And then we want to, the object boundary is where you would have the like the cross-tenant portfolio that we've had as a command. And we would read that cross-tenant portfolio with our parameters, and we'll just have that object boundary. The hidden money endpoint is where the function boundary comes in, and we essentially execute there a bunch of commands that would allow us to access that. And then we launder the money using the agent. This is the tool boundary. This is where the agent crosses the boundary, and there is almost no turning back from here. But this is the same session we're talking about, by the way. This is not like, this is not separate sessions. This is like the entire chain that happens when you are going there for the session context. The worst part actually is that sometimes I don't see the TTL, the time to live, on those sessions, and especially important where you work with money. Many people assume that if you are creating the financial services other than a banking app, you don't have to like strike people from the app every like 10 minutes or whatever, but you have to, because when working with money operations, you got to think about those levels of authority. So ambient authority, I just wanted to dedicate a couple of minutes to that, because I mean, it confuses the deputy, and this is essentially the context. The context. It's a really old concept, by the way. Like, it's nothing new, but it is so applicable to this AI agents interactions with the applications that you have already created, like maybe 10 years ago. So this is where the request simply carries the power to actually access something that was granted to another user, and you're bringing the context along with you. So, for example, cookie, a browser state, like maybe tenant ID, or like a tool token or something like that. And you're saying, oh, I am who I am, and obviously the computer doesn't see you like a border patrol, and it can't decide. So the browser becomes the bearer, and then the API trusts the object ID. Then we have the routes that would trust you as your role now is closely mapped to the original API. And especially if you have a loose API, that is the case. And then the agent will become the deputy and will orchestrate the entire chain, will trigger the event after event, and the money will draw from there. Yeah, this is what I have always in my mind whenever I make a decision about what I need to set up a system like. So I think it's very important to draw here the importance of discussing what the system can do and how, and especially emphasizing the most important parts where you're discussing the actual contracts of the agents between what tools can be like a talk, and between what tools we just need to absolutely have no boundary, like they can't access and see each other. So basically what I have shown you, the chain of events that were triggered one by one. These are basically the evidence of like where we are reusing the same stuff all and all again. And I mean, yes, we can execute it from terminal. We can also do it from like live JavaScript console or whatever, accessing the server and stuff like that. So I think the app needs to know who is acting at this point, and authorization needs to actually prove who is authorized to do what. So we can replay the session. I mean, this is pretty much what I have done. this is actually interesting. So yeah, on the side of the sessions, when we have a wrong object, there's a thing called Bola. I think this is this is here. So I just wanted to so Bola is like a broken object level authorization. It's like it's a concept that is an issue where we expose API, but we expose the actual identifiers, the object identifiers for the actors, and then we failing to check who can do what, like what the actual permissions are. So this is basically that concept in working, and I think it's OWASP concept, like essentially you can read it, and that's why I wanted to tell about it, because this is cross-tenant portfolio setup, and we were talking about two different actors acting as one because they are sharing the backend. So yeah. So yeah, the UI, we obviously don't care about the UI. Basically, if we hide a button, it doesn't hide it from the command, and we can still access it. Obviously, if you have ever interacted with a testing tool, you could pretty much find any buttons that are hidden. And the UI, when you're saying, "I'll remove that button," no, if that button sends money or does something sensitive, obviously we're gonna need to get rid of it. But yeah, I think this is very important here. So yeah, the money laundering, as I said, money laundering through the tools is an actual problem, because we want to not trust the agent to make the second approval. We need a second person, the actual call maker in the system, rather than just creating a tool that would be approving someone. Imagine that, you can put a tool at the boundary of the first approval, that makes sense. But when you're doing a second approval as a tool, that would be nonsensical, because you want to be 100% sure that this works. So granting the tool accessibility and ability to do the call based on the context, I don't think this is satisfiable for the system. So the receivers is the bank. I just wanted to mention that we got the we got that balance because the pipeline worked, but it's not the case all the time. This is one of the events I have actually seen. So this is a simple case relatively. But I think the visible pipeline here is that we have the replayable steps, like the context, and then we are just replaying that, and we can do that many times actually until the session leaves. It's up to us to do that. MCP abuse, as I said, is a common thing that happens. So MCP standardizes how AI apps would be connecting to the tools. However, many times we fail to set them up for success from the beginning. So what data sources they can access, what services they can access, and we assume that if the model can generate a relatively human text, we just let it. We cannot do that, because the security question is who can trust what, and whether the prompt would be safe. But this is not a prompt injection that I have shown. Obviously, this is session replay, and the actual payment APIs are probably the most risky category here, because we want to protect the actual money actions. If someone changes an information piece in the system, we don't really care in that sense. But it helps to secure your application from any of those, because who knows what the next zero-day exploit will unravel in the system. So yeah, that's enough for the demo. I mean, it's pretty much self-explanatory. Grant Pact, this is the tool that we have been developing for the most part of this year. It is going to be launching on the 1st of August this year, and it will have all of the necessary tools to set the contracts correctly and create your permission layer. So this is essentially a layer where you integrate it in your system. It checks in your repositories whether your authentication works as supposed to. I specialize in authentication and I am access management. And this is what prompted me to do that, because AI models, they typically are unknown and there's many of them, and agents can be regenerating new agents, and we lose track of agents in the system initially. And then when it comes to the incidents, we cannot trace back clearly what happened. So this is what we do. We're tracing them back. We're showing the exact chain of events that that executes a particular action, and we care about the agent, where we retire the agent, where we adjust the capabilities of an agent based on the actual logs that we provide. We have a big dashboard that is a massive for different cases and use cases like for different scenarios, and it covers the most important attacks for the specifically LLMs, and not just the browser attacks. So this is something to wait for. You can connect with me on LinkedIn. You can see the announcement as soon as it launches. Yeah. So this is again, this is where you can connect with me, and I'll take all the questions you have.
Excellent. I see a question already.
Hi. So, when you walked us through that scenario, do you see the root cause as actually the account? Like, see, in an ideal scenario, if the user account, security profile, all the typical, like the segregation of duty, authorization controls were defined well. Can the AI agent still, can this session hijacking still happen? Does if the agent, the layer of, the agent level security is missing, but let's say you have perfect 10 on 10 controls for your basic hygiene controls on identity and access management, could this still have happened?
Yes, there's no security proof validation. Like, you can't secure entirely your application. That's why you still pay £30,000 to do a pen test on your application, because you need to still be aware of all the things that can go wrong, especially when you have an MCP and you have tools that execute on behalf of you, where you grant access on behalf of your employees. You essentially are risking as well for the hallucination part. So it can happen. Especially if the tools cross somewhere in the context, and maybe some prompt that looks really easy, but actually tricks into hallucination part. It can start like doing that, and if you don't have proper guardrails, you can still give access to the wrong tool. So you gotta make sure that you have the entire chain of execution. So session hijacking, you can have the HTTP secure cookies, like you can have those security measures. They only serve as a helpful tool rather than a complete security solution. So you can't secure. Browser is a very vulnerable environment, and if you're running applications in the browser, you need to be expecting that sometimes if you don't have enough layered onion system, an API that protects that, you can't expect the system to fully be secure. So I don't think you can have a really secure application that would be unhackable. You can hack anything in that context.
So I'm not sure if it is relevant to what you talked about, but there has been concept going on around passwordless. So do you think having a 100% passwordless implementation within the backend of the organization would prevent what happened in the demo? Second question, I think she already touched, but I had a version of it. So if we implement SODs for agents, will still this happen?
Sorry, the second question?
So first question is, if we implement passwordless within the organization, will the demo that you showed or the topic that you discussed about, what are the possibility of it getting hacked? Second, if we implement SODs for agents also, just like we do for humans, does this happen with AI also?
Yeah, okay, thank you. Yeah, so the first question, obviously passwordless, MFA, 2FA, anything that you implement for the login. I mean, it can work, but it's just a secondary authorization mechanism. As I said, the login page left the chat for this demo, and this is where we have already logged in. We have already passed that. This is not the login part. That's why I'm saying this is inside the application where he went in, logged in for us, and grabbed that HAR file and sent us the active cookie. So until that cookie expires, you know, passwordless doesn't do anything, doesn't do much for us. It's still, there is going to be a session. So yeah, gonna tackle the second question though. Sorry, I lost the track. So you said AI tools, whether we can secure and put guardrails for the AI tools, yeah. So the AI tools are going to be worse than humans, because if humans have human factor, AI tools are unpredictable because they can generate continuously until you have money in your account. So obviously you're going to expect that there's going to be many discrepancies. Maybe the simple cases are going to be covered. Like, I don't know, session replays are the type of tool that you can grab it from the AI tool as well, because if you prompt social engineer the attack and trick your AI model into giving that, and if you don't have a boundary at the back end where you have a security layer, like where you define the rules for that model, it's still going to give out the information unless you have that, you know, the layer that you can otherwise get. But there's many things you can say to the AI model, and you can't fully safeguard. What you can do is separate your APIs, and you can create completely different APIs for different contexts. You can also implement RBAC, a role-based access, where a certain AI model cannot absolutely have context of another API. However, through other tools in the company, it can still get that access if another tool delegates. That's where I'm saying, like, on the scale, even if you have different APIs, if you have many guardrails around it, if you allow one tool to make calls based on the current context and grant access permissions to other AI tools, then those AI tools are going to give the permissions to to other tools through that. So that's why I'm saying, like, you don't integrate AI model unless you have proven that your application is secure, at least of the, on the side of the normal typical attacks that happen, because it's fintech, it's finance.
AI is also software, just a reminder. This is why
Yes.
OWASP and everything we do is still valid, because AI is still a piece of software.
Yeah.
I think, this is where I wanted, well done on the demo there, and making the fonts bigger. That was really good. And being under pressure from us. I think, some of the scenarios you're describing, that's exactly what I lead the OWASP Top 10 for agentic applications. And there we kind of talk about the two different scenarios where if I use my own identity for a tool, then you can have the confused deputy scenarios where, maybe you don't want to give your agent the rights that you have. And the other one is if you use an agentic identity, which is our recommendation, is what kind of permissions do you have in addition to RBAC. So I think I would encourage you all to look at that instead of were unsafe. I think we should integrate AI, but we should look at those attack surfaces and the mitigations and use tools like yours to secure things. And I would encourage you to register with something that we have that's called Landscape for the Generative Security AI project, where people can find you. Thank you.
Yeah. That's a great addition. Yeah, I think authorization is important here. That's why it's not only the RBAC that you authorize with. There are many different factors that go into the authorization layer. And that's why I say you can't fully integrate an AI tool unless you have safeguarded the application beforehand. So you got to sanitize it. You got to sanitize the output it gives. There are many factors that you need to cover before you have that. It's just a really long talk for that.
Right. No more questions? No? Okay, let's thank Viola. Thank you, Viola.
Thank you.
Thank you very much.